So what are you doing on a boring Wednesday evening? You check the mailbox and you find a big blue package. And you know, it's your new PCBs that just arrived. So you go down to your basement, you waddle along, you unpack them. There's a lot of tape. And there's even more tape. And then you unpack the magic. It's interesting, if you're coming from a software world, it's kind of like writing code and then waiting 2 weeks for it to compile. This is what electronics feels like. Alright, that looks good enough. So this flashboard, the PCB for the module, and the connector board, and quickly checking the SMT stencils that also got delivered. It made life much easier actually doing SMT. And the first thing you do is like a crafts project. You take old PCBs. As a recommendation, always order a few too many. And you kind of like create this little template where this fixture, where your PCB that you're about to put components on is going in the middle, and you kind of like box it in between other PCBs that you already have. And you do that. Shout out to Pack Help for providing me with very nice tape. And I'm also breathing, which is nice. And of course, I'm trying to be diligent here. I'm trying to be careful in what I'm doing, but it doesn't have to be perfect. So usually when I order components for displays, what I do, I only place components on them at home, kind of like I do the components at home for a few to see if everything works, and then order them fully assembled from JLC PCB. And here you put the stencil on top, and then you need to be a little careful because at this point you're going to also fix it using tape. So you can basically just put it down, and now the solder paste goes on it. I took some fresh one. The old one that I had was not like paste anymore, it was like crumble. And you take that, and you now take more PCBs that you had already flying around and use them to apply the solder paste to the PCB below. You kind of like get a feel for it. The first few times I really messed it up, but now after some trial and error, you actually get a feel for it. This time my feel was completely off, and I figured I need to actually apply some more, but it's cheap. So off you go. You need to actually apply quite some pressure, but it's a fascinating method to actually apply solder paste, and it works really well once you get the hang of it. It's much easier than manually soldering using a solder iron. So I did it so well that it was actually quite hard to remove. It was not very easy. And looking at the result, it looked really nice. So especially you want to take care about the smaller pitches. And then over to the workbench for actually putting all the components on it. What I usually do is I print a schematic, because I have the schematic markings, like the component numbers on the board. And then I kind of like take my color-coded little boxes for SMD components and, well, go through them one by one. I usually do 2 PCBs at the same time, so I'm putting the second one in the frame right away. And now you can see me in a speed up version as the human pick and place machine. I think I'm doing a great job. Also shout out to my hair for occasionally being in the picture. And first I usually like to do the small and cheap components. And then as I progress, I go to the more expensive ones like those Elcos. And later also the ESP and the TMC, like the stepper driver that goes on it. Those are like the 2 more expensive components. So I'm trying to only apply them once I'm sure that everything's working. Off we go. Got this little hot plate, using my MacBook charger to that actually do the soldering. And again, it's pure magic from my perspective. It's heating up, usually do around 170, 180 degrees. You wait a moment. And this is always magical, like the moment when the solder paste is actually melting, like those tiny metal particles in the solder paste. And yeah, basically you're done. I did the same for the flashboard, because obviously you cannot use a PCB unless you flash it, or you cannot use the controller unless you flash it. I then figured out midway that I actually was running low on a certain connector, so I entertained the side quest, actually desoldering, using my desoldering thingy, this from an existing board. It took, for sure, I do not do that often, so it certainly took like 20 minutes to get that right, but I need the connector in order to be able to flash the board. But at the end of the day, it worked, so that was the most important thing. Then quickly soldering the flashboard. And so once that's done, one of the steps I always do, I quickly check for the finer pitch components. Here it's like a CP2102, I think. If all the pins are connected properly, you can see there's some shorts there. So what I quickly do, take some solder wick and just make sure that's fine. So I did that. Now I can use it. So then there's always this big moment when you actually connect it for the first time to USB. And the first thing I'm checking if it just lights up and doesn't set the house on fire. So never use a computer for that, obviously. So it's lighting up, that's good. Which means that most of the parts are actually working. The 12 volts on the flashboard are actually to provide the modulator with power, because the steppers might in some situations need a bit more power than I comfortably provide with a USB that is not following the PD protocol, which this one obviously isn't. Then next step is to, well, actually flash the ESP that's on the board. You can see a lot of blinking and a lot of blue. That means that it's actually working. And there's of course a lot of extra components on the board. You see it here blinking. That means that it worked. So the final step is to add all the extra through-hole components. That is mostly JST connectors. That's connectors for the daisy chaining, which is used to connect displays to each other, like display modules. And then there's one connector for the Hall sensor, which is then later used when it's running to determine the zero index point. It's a very quick affair, usually. And then once that's done, you go over to, well, connecting the stepper motor. So you usually have some cases flying around that have incomplete wheels, like the drums of the split flap module are not completely equipped with flaps. And I use them for experiments like this, where I just want to make sure that a new PCB is completely operational. And for this iteration here, it's quite a big design jump from the last PCB generation. It's a bit of a more robust design. So I gave it like a 50% chance of working on a first try, because sometimes you just forget stuff. Sometimes you just make mistakes. And here I put the module a bit differently, so you can see if it's actually flapping and working. So quickly over to the PC. I can control it via serial, but obviously also via Wi-Fi, so you can hear it already. And here you can see it, that it's all working exactly as it's supposed to be, which is pretty cool. So that overall took around 2 hours from opening the GLC PCB package, soldering everything, assembling it, soldering it, making sure everything works, doing some checks, to actually getting the fully working display, as you can see here. Cool. Thanks for listening in, and see you next time around.